Thanks. It's a great intro. Keep going. All right, fine. Well, that's useless. Let's even not even worry about the computer for now. Ooh. Well, echo, 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 echo. This is hilarious. I could do this all day. Where is this coming from? It's terrifying. Where? Hello. Cool. That was terrifying and great at the same time. Hi. My name's Samir. There aren't that many. Forget the stuff on the screen for now. It doesn't make any sense right now anyway. I wanted to give a talk about type systems, and because I like type systems. But I realized something a few weeks ago that made me question this a lot, because it turns out, while I really like type systems and I really like talking with people about these things and computer science stuff in general, it turns out I really hate giving talks and I really hate attending talks. And I've given maybe, I don't know, 20 or 30 talks like this, like anywhere from like small meetups, like 5 people in the room, to like large conferences. And it turns out I've never enjoyed it, and I only just realized this. So I want to do something slightly different. And this is partially because there'll be pizza arriving in 10 to 15 minutes, hopefully. And so we're going to need to take a break anyway. But also partially because I wanted to do this anyway, so it turns out that works out. What I want to do is, I'm standing up here, you are sitting and watching me. I would like you to interrupt me whenever the hell you please, right? There are not that many of you. Like, if there was 300 of you, I'd probably not say that, because then we just have a talk of instructions. But I have probably, like, if I went quickly, half an hour of material, and we have an hour or at least, right? So I figure we got time for interruptions. I'm going to show you a lot of code. I have no slides. I have no, I barely prepared. And I'm just about to make it up. So if you interrupt me, as far as I'm concerned, that's just adding to my material. So that's a win for both of us, right? So with that in mind, this is my attempt at a talk. Let me start somewhere else, actually. So who here knows JavaScript? Who here doesn't know JavaScript? Okay. Who here knows enough JavaScript they can read it if I write some? Okay, cool. That's all I need. Because what I'm about to talk to you about doesn't really have much to do with JavaScript. It just has a lot. It's just the language I chose because it's better than Ruby. No offense, Rubius. So, oh Christ, it's blinding. Oh, hold on, let's just check a couple of things. So, why now? Did I not do that? It says I'm screen sharing. It definitely says you are screen sharing. I'm gonna let you figure it out. All right. I don't know how well a live stream is gonna work when I don't have any material, but let's see how this goes. So what I want to do is explain to you a little bit about what a type system is, and before that, I want to. So I figure the best way is just to ask the computer, right? Because the computer knows everything. So this is Node. Oh, so I'm dying. Excuse me. If I pass out halfway through this talk, call my mom. I figure the easiest way is to ask JavaScript what the type of a thing is, right? So a type system is basically a fancy term for a bunch of types. The word type is important, the word system is not. So let's ask JavaScript about types. So, for example, you can do things like this, right? You can say, what's the type of 3? And it says number. All right, it's doing okay so far, right? Hold on, let me just... No. Ah, I don't have to do this. I just want to add some padding. Oh, yeah. Cool. Makeshift padding. So the type of 3 is number. Great, you all knew that. The type of the string 3 is, funnily enough, string, right? So far, hopefully no surprises. Maybe there are some surprises. Interrupt me if you get confused. I want to show you one more thing. So, I don't know, let's say this is an object, right? So for the Rubyist, object just means hash, so don't panic. And that is also an object, which is slightly more confusing because as far as I was concerned, that was an array until about 3 seconds ago. Also called array in Ruby, conveniently. Who here started with a language that's not Ruby or JavaScript? Oh, you two don't count. Okay, which one did you start with? SQL, cool. And you? Which language did you start with? Python, cool. Okay, do you know some JavaScript, or at least some, maybe more? Cool. So I don't need to translate, hopefully. What now? You don't count. How long have you been doing this for? There we go. He's just here for the pizza, and there isn't pizza, so joke's on him. So JavaScript has like a basic type system, right? It knows that this is a number, and it knows that this is a string, but it breaks down as soon as you look at anything more complicated than that. So we have objects, and as far as it's concerned, every object is the same. I want to explain what a type is, right? So let's take number. What can you do with numbers? Someone just shout them out at me. Add, and subtract, cool. Keep going. Multiply, divide, keep going. Custom. So like turn them into a string maybe? Cool. Yeah, you can do that. You can do like 5. 5 to string. Cool, and you get the string 5, right? We asked the type of that. It's definitely a string. What else? What else can you do with them? Compare them, cool. So like 3 is less than 5, probably. But it's JavaScript, so we don't really know if that's true, but we can hope, right? Is 1 plus 2 equals 3? Oh, it is. Look at that. They fixed that. They didn't used to be true. It's actually still, it works now. It used to be 3.0000000000004. Don't ask me why. I can explain, but I don't want to. Okay, so we can add, multiply, divide, blah blah blah. Turn them into strings. We can compare them. What else? We can do modular arithmetic. Cool, that works. Anyone else? Cool, so we can convert them to booleans. Yep, definitely a thing. Oh, they fixed that too. That's nice. We're getting somewhere with this language. Great. Carry on. So we can do loads more stuff, right? Because I can write any function that does anything else with Java. I can write a function that, oh, in fact, there's already one, right? So what was it? Date from, I forgot what it's called. That's the one. So I can turn into a date, for example. I can use the math library to do all sorts of fun things. Right? Oh, we got, that's a weird one. Hold on, let me just move that up. Open more shells. Ignore the padding. So we can do all sorts of things with numbers. What can't we do with numbers? I mean, it's JavaScript, so you can actually do a lot of things with numbers, which you should be able to do. But things like concatenation, right? You can't just concatenate 2 numbers together. If I try it, like, it doesn't work, right? Like, I need to turn it into a string first, and then I can concatenate strings, right? What else? Give me things I can't do with numbers. Like, I can't tell whether a number is on a Tuesday, right? I need a date for that. I can't tell whether a number's price has gone up in value, because I needed like an item in the shop to do that. There's loads of things you can't do with numbers, right? And that's what type means. Type is just a list of things that you can do with this thing, right? That's not what a type is, but what it means, what it gives you, right? But more importantly, it's also, by negation, the list of things you can't do with this thing. It's an infinite list, but it's still a really useful one, right? If you know what you can do and what you can't do with a thing, it gives you a lot of power, right? One really useful thing about languages like JavaScript and Ruby and other languages of the sort, what we call dynamic languages, interpreted languages, is that they allow you to ask this information at runtime, right? So at runtime, I can say, what is 3? And it says number. Great. I can say what is foo, and it tells me it's a string. I can say what is the array 1, 2, 3, and it tells me it's an object, which is not very helpful at all, but we can get there, right? So, go on. What makes a language not like Ruby or JavaScript? I'll show you one example later in the talk, but to give you brief idea. So there are many different dimensions in which you can categorize a programming language, right? Just like anything. So one is whether it's compiled or interpreted. Now that's starting to mean less and less because everyone compiles JavaScript now. But basically what it means is the thing that runs the thing. JavaScript is a language where I don't usually have a compiler that creates an executable which can then be run directly by my operating system. Instead, I just give it JavaScript and it runs it immediately, right? And you can see that because I'm just typing JavaScript and it's evaluating it. Whereas a language like Java, you can't do that. You need to take the Java file and turn it into what's called bytecode, and then that bytecode is run by the Java virtual machine, right? So it has a conversion process first. So that's one dimension. Another dimension is the flexibility of it. So JavaScript is a dynamically typed language, which means that I can do things like this. So like x is 3, now x, and the type of x is number. Now x is 3, the string, and the type is a string, right? So I can just change that stuff. Whereas in a statically typed language, when I define a variable, I need to also tell it what type it's going to be, right? There are ways to get around this, like JavaScript. Java has the wonderful object type, which basically means whatever the hell I please. But it also then massively constrains you, because then if Java doesn't know what type it is, you can't do anything with it because it builds in the constraints by default. We'll get into that stuff later. So that's a few examples of what a type system will give you. Here's my problem with JavaScript, right? So say I have Alice, who is a person with a secret, and the secret is, I don't know, 97. Very, very important secret, don't tell anyone. And I can ask Alice for the secret, right? And the type of Alice is object. However, my problem is that Alice.name is undefined. Hey, I can't read that on my screen, but I can read it on that screen. That's interesting. Sorry. So what JavaScript didn't do is help me out very much, right? So say I happily thought Alice had a name, and then I did some other stuff, and it immediately scrolled off the screen. And then I said, hey, that name, let's make it uppercase, right? And I get a type error. And finally, it's giving me the type error, right? But name's been undefined all this time, right? And it only gave me the type error because I tried to do something with a value that was undefined. It also works with null and in certain other cases. Or if I'd thought Alice could jump, right? So, and then again, I did some stuff, got confused. You know, this is pretty normal in a larger program. You do something in one place and then you use it in another place. And you probably don't know even how it got from A to B, let alone what it is by the time it got there. So then I call jump, and I get jump is not a function. Well, that wasn't very helpful at all, right? All right. It's almost absurd in this example, right? But it's entirely common for me to get input from a user, pass it to a file, pass it to a function over there, which then passes it to a function over there. I'm using a framework like Rails, so I don't even necessarily know how things are flowing between functions. I get confused because I wrote some of the code 6 months ago and some of the code now. Right? I may just forget. The issue is not so much someone types something and then immediately types the wrong thing immediately afterwards, but there's usually a time delay on the order of months, sometimes years. I write some code, I go away for a while, work on some other feature. 6 months later, I come back to that same code and I add another line of code, completely forgetting that this particular instance of a person doesn't have a name, it has something else, right? And that's what's valuable about it. So I just ask it for data that's not there and end up getting undefined, and it confuses the hell out of me. All right. Oh yeah, Ruby has the joy of just changing what you've got randomly. Active support is a perfect example of that. It drives me mad, basically. Yeah, I know, right? So we're going to talk about how to solve this problem. So absolutely, it's totally normal in JavaScript It's normal in Python, less so, but still normal. I'm excited. So when we get back from our break, we're going to talk about how we solve this problem. All right. So we're going to take 10 minutes to get some pizza, and then we'll figure it out from there. That's why. That's why I didn't need you to say it. What is your C? Oh, that doesn't have a type system. Does it? It's not like regular basic. It's not like Bash is very rigid type system where everything's a string. Hello, internet. Who's watching this anyway? right, good point. Hey, that worked. What I just did. It says on. I blame you. Hooray! Yes, we'll talk about why this does work and why it doesn't, right? That's actually a really good question. I want to spend a little bit of time on that. So JavaScript does have this concept of a constructor. So if I construct something with the array constructor, which is the same as going, I don't know if this actually works. I think we can do that. Oops, excuse me. Yeah, so that's exactly the same as just using the square brackets. Then I can, because that's the case, I can do things like and check whether it's an array. That's really useful. However, sometimes I create an object like this. Right, and that's not an instance of anything. Right, I just made it. And that's far more common in JavaScript than you think, right? It's very, very normal to create objects just by typing them out, right? I guess it's very different in JavaScript to other languages because you have one syntax for both objects of the form of a record. So like it has fixed keys, it has a name and an age, and blah, blah, blah. And we also use objects for dictionaries or maps. You know, the idea that we just have this bag of stuff with keys and values and we can throw stuff in and pull them out. So that leads to confusion, but we'll get onto that in a minute. So I want to show you a type system, right? So go for it. What do you mean left square bracket? Yeah. Yeah, that one I hit Control C because I typed it wrong. No, don't do that. Don't do that. Yeah. This is definitely a mistake. This is the correct version. Don't do this either, right? It's weird. Just do that. Right. And I don't guarantee that it actually works in all situations. I have no idea what it does in all situations. And frankly, who cares? So I want to talk about a type system. So before I talk about a type system, let's just look at an example of a thing. So, how's that? Cool. So I wrote a thing. I wrote a shop, right? So here's a test case. Who here knows what a test case is? Who here doesn't know what a test case is? Please don't be shy. Like, cool. So a test is another way of doing the same thing, right? So what I want from my type system is to tell me when I went wrong, right? Give me lots of warning for when I screwed up. Right? Before we get into type systems, I just want to show you an example without type systems where we accomplish the same thing. This test, what it's doing is I wrote some verification. So I created a shop thing, a thing that makes a shop, and I get a basket and things like that. And what this test is doing is it's verifying that it does the right thing. It's made up of 3 steps. The first step is what I call the arrangement, right? So I've arranged all of the objects, the values, the behaviors in my system, right? I've created a shop. I've got my wallet with some money in it. This is what I call the action, right? So I pick up some stuff, put it in my basket, and then I go to the checkout. And then the last bit is what I call the assertion. This bit is the bit that is weird if you're not familiar with testing. So what I'm doing here is verifying that it did the right thing, right? So I would typically write one of these for each concept in my application, in this case, a shop or a wallet. So what I'm doing here is verifying that it gave me the right things, that my wallet now has the right amount of money in it, and that the stock got decremented, like because I bought something from the shop, it shouldn't still be there, right? This is test.js, the very first one. Yeah, we're going to start from the left, as is typical. Yep, so no framework. This is using Ava as the test framework, but I don't really mind which test framework you use. They're all the same as far as I'm concerned. I just like this one because it gets out of my way, mostly. So that's what I'm trying to accomplish, right? So I wrote an implementation which looks something like this. So it's got a basket, it's got a shop, and then I can ask it for a basket, and then I can pick up some stuff, and I can check out some stuff, right? We'll go into details on this later. I just want to show you a couple more test cases that I wrote first. So it turns out it's very normal when dealing with domain concepts like this. For most of our checks, most of the things we want to verify, whether you do it manually or you write automated tests, or I don't really mind how you do it, most of the tests are what happens when something goes wrong, right? You write one test that verifies like everything works as usual, and then you check the 27 different things that could possibly have gone wrong in that time. So, for example, I come to the shop, like imagine it's actually a real shop on the internet, and I put my credit card details in, and it turns out my credit card's already hit its limit, right? So, what do I do in that situation? In this case, I don't have enough money to buy the thing that I want to buy. here is the test case. Right, this is just the name of the test, and then everything inside the braces is what the test does. Yeah, fair enough. So, yeah, so annoyingly with JavaScript, braces actually mean two things. They first of all mean construct an object like this, right, or like this. But they also mean here is a block of code, right, which starts from here and it goes down to there. What's your language of choice? Neither. Doesn't matter. You're cool. Yeah, so it's the syntax. I agree for JavaScript is a bit weird. That's why I should have picked Ruby. But then the JavaScript people get upset. So what can you do? But use C. Yes, make everyone hate me. Perfect. But there will be examples in other languages, and hopefully that will start to resonate a little bit more in a little bit. Okay. So moving on just a little bit. So I have here pretty much the same test cases. The only difference here is I just check that they throw and I don't check what they throw, and that will become apparent in a minute. But otherwise, they're exactly the same test cases. Let me show you the implementation. This looks like JavaScript to you? If you hate the syntax of the last one, you're really going to hate it this time. So let's scroll down a little bit. So it's going to be weird, I promise you. So I want to draw your attention to one thing, right? So here, I'm not checking that wallet.silver is less than price, right? So I'm not checking whether wallet has any silver in it, like I was in the previous example. Let me just go back to that for a sec. So you can see that here I had to check whether the wallet had any silver at all before I checked the price, because otherwise I get an exception going, you can't compare undefined to anything. So that's not useful. So what I'm doing here is doing it in a different way. So I'm using a library called Sanctuary here. Sanctuary is a type system that's built on top of JavaScript. So instead of defining this checkout as just a straight up function, it's still a straight up function. It takes a wallet and does some stuff. But I'm using this magic def function to do it, which takes a name, some stuff I can't remember what it does. More importantly, it takes an input value, give me a wallet, and an output, which gives me a list of item names, right? And this has to conform, right? So for example, if I pass in something, a wallet, which doesn't contain any silver, what that's going to do here, I get an error. So checkout should take a thing, a wallet, which is some silver, but I actually got a thing with pigs in it, right? So the value at position 1, this is position 1, is not a member of this object. The wording is a bit obtuse, I'll give you that, but the message I think is fairly clear, which is, hey, you gave me some pigs and I expected silver, right? So that's what this does. So I didn't have to check that. My type system checked for me, right? The way I defined that was a little bit more complicated, but hopefully we'll get there. I'm going to run you through it, and you're going to stop me when it makes no sense. I talked about the difference between maps and dictionaries and records. So in JavaScript, we use object syntax to represent both of these, but they're very different things. A record is a thing with fixed things. So here's an example. An item is a record with quantity, it's an integer, and price, which is itself a record with some silver, right? Whereas stock is just a map or a dictionary. So it has a string keys, because all objects in JavaScript have string keys. You can't really choose that one. And the values will be items, right? Item names is just an array of strings. Top options is the input, is just a record with one thing, the stock. A wallet is a record with silver in it. A basket is a record with two functions, pick up and check out, right? So what I'm doing is I'm defining in much greater detail than my previous type system with JavaScript, the one that thinks everything's an object. What I'm doing is defining in much greater detail what the types of my things are. I put these at the top of the file. This is actually the most important thing in my system, right? If I know all the types of all the things, I probably know exactly what the system does. If I know that a shop has some stock and has a function which gives me a basket, and a basket has pickups and checkout, I can probably figure out what the system does without knowing any detail about the implementation. All I need to know is the type signatures, right? So that's basically a full definition of my application. Go on. Mm-hmm. Right. So that's the flip side of a type system, right? So what it does is it does a bunch of checks for me. So you saw how it just checks whether my wallet has silver in it without me having to write any more code. What it also does is it makes your life way more constrained, right? So I've asked my type system to make sure that I conform to these things. Now I think because it's JavaScript, extra stuff in the object is fine. But if you had something that was like the wrong type, so for example, I don't think it would go too far. So if a price had extra stuff in it, like, and you had an item with price with extra stuff in it, I think it would complain. And we can double check that in a second if you want. That list right now. But yes, it's very similar to an interface. And interfaces and types are pretty much interchangeable. Let's see what happens here. Ah, type system did not complain. There you go. Yes. So, for example, if I say that an apple costs 1 gold, it'll say, no, I expect so. Right? Apologies for all the references to RPGs. I was having kind of a weird day. It also means that if I do things like basket, pick up, you know, the number 7. I never checked whether that's the string in my previous implementation, right? Okay. It says it's an item name, and I got a number. And I can look in my definition and see that an item name, wherever it is. Where did I find that? Ah, yeah, right. I've been a bit clever. So I can also, mousey. So say I misspelled orange, right? As I don't know, perfectly legitimate misspelling. It will also complain. Because the way I defined item name wasn't just item names of strings, I actually defined it a little bit more complicated. I said an item name is any of the keys in my stock. So it's automatically checking that my items, like anything I try to pick up, is actually in stock. Right? And I didn't have to write any further like code. And if I had lots of things that deal with this, so for example, if I had to pick up my thing and put it in my basket function, no, I don't want this anymore, I want to take it out my basket, or go to the information desk and see if they've got any more apples because they're no more on the shelf. The same type. I only have to write the logic once. Right? By putting this logic into a type, it actually becomes a kind of behavior attractor where all of those validation checks go into one place instead of me having to do it everywhere I write a string. Question or comment? It was like, what was this? Oh yeah, just gesticulating. Okay. Speaking of pizza, I'm gonna need to take a break in about 10 minutes. Or at least, I hope there's a microwave in here. Sweet. All right, so I don't need to take a break. So, what my type system is allowing me to do here is specify all my validation checks once. An item name is one of the keys in my stock, so it must be in apple or orange or whatever the third thing was that I've forgotten. Healing potion, I think. Oh yeah, sure. So it's here, right? So if it's not one of those 3 things, it will fail. And I told it how to fail, but I didn't have to write any complicated code. I didn't write any logic myself. I just gave it a list, and it did the checks for me. So this type system is kind of weird. It's how much time have I got? Not actually that long. It's what we call a dynamic type system, which is very strange, right? It's not typical, but I think it's really powerful, and also really powerful, especially if you just want to write raw JavaScript. You're used to writing JavaScript, or for that matter, for Ruby. There's one of these for Ruby too, and there's one of them for Python. Not this one's called Sanctuary. I don't know what the other one's called, but you'll find them. Excuse me. What they allow me to do is put all my validation checks in one place while still writing just straight JavaScript. It's ugly JavaScript, but I take ugly and functional over pretty and broken, personally. Any questions about this before we move on? Any questions along the lines of, I don't get it? Those are legit questions too. Cool, let's move on. I'll show you another type system. So, go on. Always. Yes. So I want to show you. I know, right? I like code that works. And I prefer if my computer would help me out with that. So a good type system will get out your way when you don't want it to be in your way. And I'll show you an example of that too. So here's another example, right? Same tests. Pretty much the same stuff. Blah, 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 blah. Right. Turn that on. I'm going to show you a type system called flow. I'm going to turn on now. So these might look familiar. They look very similar to the previous types. The difference is that we're now using a syntax that is not actually JavaScript. It's a layer on top called flow, which is a thing that Facebook developed a while back, and it works really well. We use it on all our projects. So this is a type declaration that says an item has a quantity and a price. We see here that item names is a list of strings, an array of strings rather. Stock is a mapping from names to items. A shop has stock and basket. S is an alias for stock. You can see right here. The reason I've done that, I'll make clear in a minute. A basket lets you pick up stuff and check out stuff. It takes the wallet, gives you items. Blah, blah, blah. Same stuff, right? The difference is, unlike my previous example, I can actually read the code, right? Because it looks exactly the same as the first example, right? Reason is, my type system here is way more clever because what I've done is moved it from being a dynamic type system, where it checks all the things dynamically, to what's called as the code runs. So you saw the output in the test cases because it ran the code and then failed when the type was wrong. This is a static type system. It actually goes away at runtime. When you run the code, it just deletes all the types, right? It's called static because you do the check up front with the static source code, not with the runtime stuff happening in memory on the computer, but with just the text file, right? That's what we're analyzing here. You can see here, because it knows that a shop returns a shop, I don't need to put any more types in because it knows what a shop is. A shop is the thing that gives me a basket. A basket is the thing that gives me a pick up and check out, etc., etc. Right? I can show you what the output looks like. So you saw, I've still got those two test cases. So one that lets me pick up Bigfoot and one that helps me to, tells me I can't play with pigs. And this is what the output looks like, right? So I didn't run the code. This is purely looking at the text. I didn't run anything. So two advantages. One is it can do a lot more checks because it's not checking the values that go back and forth, but all of the possible values. It doesn't try and generate all possible values, right? It just knows that all the possible values for number are all of the numbers, the possible values for item are objects with price and a quantity, etc. So it sees here that Bigfoot does not correspond to my item name. And it says here that this wallet is not a legit wallet because it doesn't have the property silver, right? And this is doing the same thing. It's being quite lenient in that sense because it's just checking this property silver. It doesn't care that it also has pigs. I can make it more strict. Let me show you how to do that very quickly, which is just by putting little bars here, which means this is a strict must have silver and only silver. Right, and then you can see that it also says that you can't have pigs. Not a thing. I really should have put some pig gifs in here, but you can't get them into a terminal. So, yo. Okay, so there's loads of good reasons to use a dynamic type system too. So a static type system will give you better reporting because it can report this stuff. It can just check all of your code at once. It takes like a second, right? You don't have to run a bunch. You don't even have to write the test. Whereas for the dynamic type system, I still have to write a test because otherwise I'll never verify that the type is correct. If you don't write the test, you'll find out in production, right? your user will get the error, not you, right? Which is helpful, I guess, but you might want to do a bit better than that. Yeah. So with the static system like Flow, you'll always get the errors. Whereas with a dynamic system like Sanctuary, you won't get an error unless you actually call the function. which means you need to write a test case or just do a lot of manual stuff in the repo or something like that, right? But there are lots of good reasons to use a dynamic type system. One is that you have an existing code base, and you just want to add a few types to it, right? You can also do that with Flow, like you can turn it on and off per file, but it makes it much easier to just add it in one place. It also lets you do really useful stuff, like you saw how I just used the value of stocks in my types, right? And so I could create a type based on the actual runtime value, right? So that was really useful. It also allows me to just use standard JavaScript, no compiler. So and specifically with JavaScript or with Python, etc., it allows me to use that language directly without having to add an extra layer on top where I have to strip those types out, right? Because at least with JavaScript, this is not valid JavaScript, right? I have to delete them. So you have to use Babel and a bunch of other plugins just to delete them. So it becomes a compiled language, which may not be what you want. You can't use these in the REPL, for example. They don't work. Whereas with Sanctuary, you can absolutely use them wherever you can use JavaScript, but it's just standard JavaScript. Works in the browser, works everywhere. Right, so there's lots of good reasons to use a dynamic type system too. I prefer the static ones, but don't let that stop you. And it's a preference, it's not a fixation, right? I'll pick the right tool for the job. So here we have the same checks, right? So I didn't need to check that the item name is correct because it's capturing the type of the stock, which it knows has three things, apple, orange, and the other thing. And it makes it part of the shop, and the shop makes it part of the basket. The type of the stock goes into the type of the basket, which goes into type of the item name, so it can verify that. So an item name is just like we did before. It takes a stock and it returns, and it can be any one of the keys on that stock, which works fine in test cases. But this wouldn't work in production code because my stock is probably dynamic and comes from a database. You can't do any static checks on that, whereas you can do dynamic checks. There's another advantage, right? Any questions about this one? Is it starting to make sense yet? See some of the values, some of the pain? I'm going to say a bit more pain. So, again, very similar test cases. The main difference is instead of using straight up objects and functions, I'm using classes. So you can see here I say new shop because I've used a class. Who here doesn't know what a class is? Don't be shy. Cool. So instead of a function, a shop, I create a new shop. Same with the item, same with the wallet, right? So here's what my type system looks like. So Flow allows me to annotate part of my class directly. So I can say that a shop has a constructor which takes stock, and in this basket function which returns the basket. So this is quite nice in that it reads a lot cleaner. I didn't need to define all my types up front. That's called structural typing. When I create types separate from my code that define the structure of the code, define the structure of the data that's being passed around, called structural typing. The main difference between structural typing and what this is, which is nominal typing, like the objects that are produced by this class have a type of shop. The main difference is that structural types are separate from the code, whereas these types are married to the code, right? But this basket function creates a basket, this new basket constructor, I should say, produces a basket. The only way you can produce that basket, you cannot get a basket any other way, right? You must call new basket. Whereas in the previous instance of the code, anything with a pickup function and checkout function that work with those types is a basket, right? That has advantages and disadvantages. The advantage of this style is it's very clear what a basket is. A basket must be one of these, right? This is a basket, right? This is the only basket. If you see a basket, it's here. The disadvantage is I can't add it in later, right? So one of the advantages of a type system like Flow, when you use it structurally, is I can just go in and add some types later, and it will tell me where I've screwed up. Whereas this way, you kind of have to build them in from the start, otherwise it's not going to fly. Another problem. So you see here, I'm still passing around this S type variable, which allows me to check that it's actually a valid thing in my stock. Give me one sec. run that, you see we get the same errors. Excuse me. So I still needed to use structural typing in order to carry the stock, like the type of the stock around with me, because otherwise I would just be working with straight up item names. And I couldn't do that. I can't do that with nominal typing because that item name isn't defined anywhere. It's just an alias string at the end of the day. It's just a string. It's just a very specific kind of string. But otherwise, it works pretty much identically, right? I have these classes, and it does the same thing. The only difference is I'm defining my types at the point in which I'm defining the functions. They're connected. They're together, right? The types are intrinsically bound to the names. Whereas in the previous example, it was structural. So there's another type system, right? It happens to still be using flow, but otherwise it's pretty much identical. And that's what the code looks like. So I think that's about it. That one went faster than I thought it would. Maybe it's the same thing. Any questions? Any questions about the code first of all before we get into the types? Does it make sense? Does this code make any sense at all? Someone say yes, please. Good, I'm not. Go. Oh, okay, good question. Are you a Ruby coder? Cool. So in Ruby, you'll be very familiar. Oops, I didn't mean to do that. With so you'll do things like oops, sorry. So that is some Ruby code that takes the list 1 to 3 and then adds 1 to every element in it, right? So in JavaScript, we have a very similar syntax, which looks like this. You don't have the range syntax, unfortunately. No. Right? Make sense? So, and the arrow is just these two characters. It just, I changed it to my editor, joins them together when they're close together because it looks cooler. Wait. So we're talking about this? Oh, sorry, I thought you were talking about this. Okay. Right, that's an even better question. Right, so what that is, let's see. Let's find a better example, because that's kind of a rubbish one. So, yeah, there's no good example here. So, right, so what's the type of that? Someone tell me. Array, cool. But not quite, right? It's actually array of numbers, right? So what the angle brackets do is they allow me to give, like, it treats the type as a function, and I can give it another type. So it's not just an array, it's an array constructed with the number type, right? And what that means is this is constrained only to, it must be an array and it must only have numbers in it, right? So that's what I'm doing here. So this is a little bit of magic, as it were, to make sure, where is it? So in this case, it's a little bit of magic to make sure that not only is it an item name, which is really just a string, but it's an item name parameterized with the stock, right? So I'm passing the stock to the item name. And the way that's defined is it takes the stock and then it says, I am one of the keys from that stock, right? So I'm using this to construct a new type every time I use it, which takes information from that one, right? So we do it with arrays all the time because it's an array of numbers, array of strings, array of items. You know, this is just syntactic sugar for array of string, right? Otherwise, it means exactly the same thing. We just write that because it's quicker. And this is actually that's a better example. This is just an object from string item. Right, so that stock is an object with two parameters, string for the keys and item for the values, right? So that's all that means. Any other questions? Any other questions bouncing off that one? Marvelous. Let's move on. Oh, no. Why? Just load a thing. Talk amongst yourselves. Grab a slice of pizza. You have about 30 seconds. I gotta load Java. It takes a while. Someone play elevator music. Rob, can you play guitar? Is there still a guitar there? No, they took it away. Damn. I learned how to play the ukulele last week. It was really fun. I recommend it to everyone. Oh, yeah. Mm-hmm. But they're basically in order, which means you can play the 4 chords very quickly. So I approve it. All right, so let me just get this on screen. Where is my screen? There's the screen. Yeah, boy. Oh, that's so laggy. My computer is not handling this well. I mean, yes, because who's got the time to do all of the things? But they are better there's some ways that are better in certain situations, for sure. I'd argue that the only way that's definitely worse is not bothering. But it doesn't mean you should always use types. It's more that they're probably at least going to be useful some of the time. Just like any other checking feature. I don't know if you're, I'm sure everyone, or not everyone here, but I'm sure a lot of people here have come across things like EFLint, which is a linting thing, which just tells you when you made a stupid mistake of some kind. People use tests. There are lots of different ways you can get the computer to do the hard work of verifying your code is good. This is just one more way. I'd say take advantage of that way as much as possible because he's got the time. Yo. Yeah. That's legit. Yeah. I'll talk about my day job in a minute after we finish because, yeah, I think it's really important to like not leave the hard work of finding bugs for humans because they're very bad at it. Uh, no, humans. Yeah, including users. Granted, you don't want your users to find your bugs. If your users are finding your bugs, you've done something wrong, or your Facebook. So what? Yeah. Mm-hmm. Got a friend, Marit Piaki, who gives a lot of talks on the importance of manual testing because it turns out you don't think of everything. And her job is basically to figure out what the developer didn't test and then test it. She's very good at it. So this is Kotlin. Who here knows what Kotlin is? Cool. So Kotlin, who here knows what Java is? Right, that's basically everyone. It's a programming language. It's an old programming language. Kotlin is basically an update, right? So the people at JetBrains who have been working with Java and making Java editors and stuff for a very long time decided they didn't like Java anymore. So they made something better. I think it's better. I only started programming it yesterday. This is some Kotlin code. It's the same, right? It looks very familiar because it's just the same thing we wrote last time. It just happens to be in Kotlin instead of whatever we wrote in before, JavaScript, I guess. And you can see that we've got the same thing. We pick up an orange and an apple, we put it in the basket, blah, 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 blah. Same things. I want to draw your attention to a couple more things. So here, so I actually know it's the same. We make sure that we throw, the only main difference, I guess, is instead of throwing string, we always throw a class, right? Kotlin is a class-based language, or mostly a class-based language. Java is an entirely class-based language. Kotlin has some escapes, but mostly it's a class-based language. What that means is the stuff that we did before, where it's mostly nominally typed with some classes, but not all the time because that was annoying. We have to do that everywhere now. So let me show you the implementation. Right. So, as always, a shop takes some stock and has a function basket which constructs a basket with that stock, right? Forget that bit. Boring. Right. A basket has a pickup function which adds the items to the basket. Two things about this, right? One is that this might throw an error, right? And in Kotlin, just like in Java, your errors are also typed. This is a good thing. Everyone hates it. Everyone turns this off, apart from me. I love it. Because what this does is tell you this function will throw a non-existent error, right? So you need to check for that. You have to check for that. The language forces you to because it's part of the type, right? This function can return a value, or maybe it will throw. That's part of the type of the function. So if you call this function, be prepared to handle it. And we do. The other thing you'll notice is we couldn't do that clever check where we check compile time whether the item name is going to be correct. We have to check it at runtime. But there's still some cool stuff about that, which I'll come back to in a minute. But otherwise, it's very similar, right? So I can check whether the wallet money is less than the price, etc., etc. All the same, pretty much, give or take. But this bang bang, right? So Kotlin knows that find might return null, right? Flow can do this too. I just thought a better way of doing it in Flow, so I went with it. Java can't do this. This is a thing that's better about Kotlin. What that means is if I delete the exclamation marks, again, error. So it says, again, type systems designers aren't very good at error messages, but they're trying. Give them a break. Only safe question mark dot or non-null asserted bang bang dot calls are allowed. By the way, I say bang because saying exclamation mark is really hard and hurts my tongue. Calls are allowed on a nullable receiver of type item question mark, right? What that means is find doesn't return an item. It returns an item question mark, right? Which means that it could be an item or it could be null, right? Null being the nothing object. This is not a thing object. What the bang bang does is tell it, I know you said it was an item or null, but I know this is an item and I just want you to throw an exception immediately if it's not. And it will. So if I put that in, it will compile, right? It's the same when I use it up here. So here I check whether the stock, actually no, that one works, never mind. So stock.find, it will tell me whether the item name is null, and then I can throw. So that's just check and make sure that, to check using the same thing. So if I were to, I don't know, delete that and then run the tests. Let's see if I can actually run the test. Excuse me. Is it running? I can't tell because I'm in presentation mode where nothing shows. Oh, how do I get out of this? This is a nightmare. Get out, get out. No, it's not running. I hate it. Try that again. The downside of a compile language is it takes forever to do anything. The upside is when it finally gets to doing the thing, it's very fast. Hooray! It failed. Version failed there. Right, it didn't throw the non-existent exception. Otherwise, it's pretty identical, right? I know that this is a wallet, and I've defined it here. The difference between Kotlin or a language like Java or a language like, I don't know, C#, C++, any of these other compile languages that you know of, compiled type-safe languages. C++ is debatably type-safe, but we'll get into that later. Type-safe if you use it right, and I've never ever seen anyone use it right, including me. The benefit of these languages is that they always check the type. You can't get away from it. You have to, right? This wallet is a wallet. There's only one way of defining, like, I've defined wallet, and it's defined together with the implementation, just like in that last JavaScript version we saw. A wallet is a class with money in it, right? There's no other implementation of wallet. I can't just make another thing with money in it and have it be a wallet. So what that means is my type system is completely coupled with my implementation, my interfaces. What that means is I have no way around it. I have to use my types. This is where it starts getting painful, right? Because there are things I want to do that I can't do with my type system. So I can't do those runtime checks, right? And sometimes they do just get in the way. What if I have a bunch of stuff and I know their numbers and I try and put them in an array of numbers? It won't let me because it doesn't know their numbers. I have to force it by doing checks, right? You can get around it by telling it, hey, I know what I'm doing, but it's generally really unpleasant. There is such a thing as too much typing. I don't mean in the laptop sense, but in the type system sense. There's probably a happy middle ground. I don't think Flow is the happy middle ground either, because Flow is a little bit too loose. It can sometimes let errors slide through. This isn't it either, although I much prefer copying to Java after about 5 seconds of using it. So with that, there's like, what, 4 examples of type systems and 1 example of not having a type system. I was working on a 5th one, but I got confused with Haskell because it's confusing, and it turns out I needed Monan transformers, and no one wants to get into that. Ask me about that one later. So I'm going to end it there, and also it's like 8:30, so probably a good time to end it. But how much time do we have for questions and chit chat and whatnot? What time do we have to be out of here? Okay, so what I suggest is we have a couple more questions, and then you can just come grab me and we can experiment with code. I've got my laptop, just screw around. We can leave it up on the big screen so other people can see what we're doing as well. We can just explore. Right? So any questions about this weird stuff? They're all on GitHub. Right. Browser. Give me a browser. I'll put it on Meetup as well. Oh, this computer is slow. It really doesn't like having the second screen. I think it's because of Hangouts, so I blame Stephen. Well, that's reasonable. Yeah, if no one's got any questions, we can talk about my job, but really it's the most boring part of the day. So. Here's the mouse. Here's the mouse. No, there it is. No, I've lost it. All right, so I just wanted to show you a couple of things. One is, if you go GitHub/my name, what's that? That's me. No, not that one, not that one, that one. So all the examples are in here. So you can see the Ava example, the Sanctuary example, the Flow example, the Flow with classes. And then I actually started this in Java and got really bored of it very quickly. So I switched to Kotlin and taught myself Kotlin, and it was fun. Turns out it's exactly the same as Java, so it's about 8 seconds, you know, which is really convenient. They actually designed the language to be moved over from Java. Like there's even a magic. In order to convert my Java code, I pressed Command Alt Shift K, and it magically converted it. It was amazing. I'm so impressed with this thing. So that was really cool. So you can find all the code there. You can mess around with it. Just try running it, see what happens. The other thing is who the hell I actually am. So I run a company called Frodo.ai. We make machines write code for humans because humans are pretty bad at it. What that means is we are building AI to handle the next generation of finding bugs in your software. Because type systems are good at it, tests are good at it. 2 problems with these is you have to write the types and you have to write the tests. Rather you didn't have to. So we're going to try and help you catch those bugs using artificial intelligence. We are, if I scroll a lot, scroll some more, hiring. So if you are looking for a job in software engineering or data or research, if you are into that sort of thing. I'm not a researcher, but I do like researchers. We use mostly Python. Yeah. But we're not married to it. It's basically whatever's good for the job, basically. All the things. Whatever you can do the job in the fastest is the right language as far as I'm concerned. Yeah. You're not allowed to apply for a job, Steven's here. Oh yeah, so Go doesn't have a type system, it just claims to. So that's all I have to say on the matter. Don't use Go, it's horrible language. If you want to argue with Ian. So Go has half a type system where it has some types, it has integers, it has strings, it has concepts along those lines. The problem it has is it doesn't have those angle brackets. So what you can't do is parameterize types. So you can in Go you can have a slice of integers, for example, but that's an edge case, right? You can't create your own container type. Let's call it box of stuff. You can't have a box of integers, right? Because you can't parameterize types in Go, which severely limits the type system in ways that annoy me. The upside of that is it's very simple and very fast to compile. So that's the trade-off they've made, right? The compiler is way faster as a result. Go on, you're going to disagree with me. So if you look at the source code of the Go compiler, they've actually re-implemented generics using French quotation marks that look very much like angle brackets as part of the type names and string replace. So I'm thinking they really did want them. Yeah, Rob Pike doesn't like them, is the long and short of it. So Go's a great programming language. It doesn't have a type system, as far as I'm concerned, because a type system that only holds your hand for the simple bits is almost worse. I'd rather it didn't bother. Go is the solution instead of a problem. I mean, that's true of most things we do. Yeah. So come apply for a job if you fancy it. We are looking for, I imagine any of you that will be applying for a job will probably fall in this bucket, but that might not be true. I'm just guessing. Because we're a software engineering / computer science meet, right? But you might be in that one or that one. I don't know. If you're a researcher in programming languages, it's probably a very basic course there. People who, so basically anyone who's got familiarity with deep learning, so deep neural networks, a PhD in programming languages or a PhD in static analysis is basically what we're looking for. Yeah, they're all PhDs so far, but it's not a rule. It's just that kind of level of understanding of the domain knowledge. We asked Rob. No, seriously, we asked Rob. He's a customer. So our customers will say no bad robot, and it will listen to feedback. It's not designed to replace people. Yeah, it's not designed to replace people. Right now, actually, the loop is controlled by me because it's not. It is basically me as a service, except the last 3 days it's been Tom as a service because I've been sick. Not that Tom. It does have a feedback loop. The whole point is it works with you. It doesn't work against you, and it doesn't work instead of you. It works with you to help you write better software. It's not supposed to replace people because I don't think that's a good idea. Well, yeah, like Atrium. Yo. Say again? Why do we choose Flow over TypeScript? Because we started without a type system. And Flow you can insert into JavaScript without having to do much, right? You just put a comment at the top of the file, and then now it's a Flow file, and it will do some type checks. And if you add more type annotations, it will do more. TypeScript is the opposite. You have to start with TypeScript if you want to write TypeScript, which is admirable. It's a great programming language, but it's not a thing you can put into an existing JavaScript project very easily. You can do it, right? You can start writing new code in TypeScript and leave other stuff in JavaScript. If you want to eventually migrate everything to use types, it's much easier to start with Flow. That's why we used it. I'm not saying one is better or worse, although I think TypeScript has better support for nominal typing, so with classes and whatnot, and Flow has better support for structural typing, if you want to just add types in later. Yeah. Because we didn't believe that code was going to survive more than a week, and 90% of it didn't. Go. Oh yeah, especially for prototyping, why bother? Just like tests, right? Why bother when you're prototyping? Just be very careful that that prototype doesn't get shipped. I threw one away last week, but it helps when I'm my own boss, right? Carlo. Ever thrown away a prototype? Yeah. Okay. So that's the advantage in starting out with type systems and tests and all the other good things that make your code great, because probably will get shipped, especially if you think it's going to get thrown away and get shipped. I don't know. I've got a lot of stuff on GitHub that's never been. Let's call it there, and then if people want to like mill about, eat pizza, have a beer, and have a chat, I'd love to. And my laptop's here, so we can carry on experimenting if anyone wants to try anything specific, but you don't have to. All right, thanks very much.